Hello everyone. Today we'll be dealing with static force analysis of slider crank with two known forces. So in the previous video we had seen static force analysis of a slider crank mechanism with one known force. So this problem will deal with two known forces. So let us see how different is this problem and how you can do it, in an easy way. Now let me first tell you how we do this in all the steps I'll show to you once, so that you will have an idea on what all things we have to do. So first we are drawing the configuration diagram as per scale, then free body diagram. After that we are taking the link 3 and we are taking moment with respect to point A, and we are finding out the values of these two components of F43 that we have taken over here. Once we get the values of F43T, I go to my link 4 and in the link 4 I draw the force polygon, and then I find out the value of F34N and F14 from there. Then I go on to my link 3 back again draw the force polygon, and then I find out the torque. So that is an overview, all of the steps in concise way I'm telling to you. Now let us go in detail on how to solve static force analysis of a slider crank with two known forces. Right. Due to space constraints, we will be dealing some of the things, drawings I'll try to accommodate within the board. So let us see how it works out. So first we are drawing all the configuration diagram. Right, now the configuration diagram is the most important part of the drawing, because we are drawing it as per scale and as per the measurements that is given. And if you get this diagram wrong, your whole drawing will get wrong. Okay, why? Because we are taking each link parallel to the configuration diagram, and if this drawing goes wrong, then your whole problem may go wrong. Okay, so this is one of the most important step and the first step. So we are drawing it as per scale. So we have two known forces P and Q acting over here. So let us do the free body diagram. So first we are drawing second link. Just considering the second link, I am drawing two forces, that is F32 and F12. F32 and F12. I am indicating it as a zigzag line because when you don't know the magnitude and direction of a force, you indicate it as a zigzag line. So these two zigzag lines and a torque. Now this is torque T2. T2 is the torque on link 2. Now coming on to the link 3. Now in link 3 I have a known force Q. I have this F23 which is opposite to F32. And I also have F43 from 4 on to 3. For that also I don't know the magnitude as well as direction, so I indicate it as a zigzag line. Now let us see the slider. Now our last and final link, that is the slider. On the slider I have a known force P acting, and I have a F14, of which I just know that it is perpendicular to the line of stroke. So I just draw the line of action. I don't know whether it is acting upwards or downwards. Direction I don't know yet. Now then I have F34, which is equal and opposite to F43. So this many forces are there on each of the links. So how do we solve solve the problem, and how we find out the direction and magnitude of each of these forces that constitutes the problem? Okay, so first let us consider link 3. Okay, now in link 3 I am going to take this F43 and I am going to split it into two components, one parallel to the link and one perpendicular to the link. So let us split F43 into two components, F43N, which is parallel to the link, and F43T, which is perpendicular to the link, right? So this is perpendicular to the link. Okay, now moving forward, let us take our link 3 and draw it in a bigger way over here. So step 3 is take moment with respect to A and find out the value of F43T, right? To find F43T. Okay, now let us see. Consider this link 3 over here. This is A, B. I have a known force Q acting over here, parallel to the side draw, and let this Q be at a distance of maybe C or something. Now I have F43N and F43T acting parallel and perpendicular to the link. I also have F23 acting through the point A. Now this Q is acting at a perpendicular distance of, let us say, X from the point A. Q is acting at a perpendicular distance of X from point A. Now how do we get this direction, this X? I just draw Q, parallel to Q, I draw another line through A. Measure the distance, perpendicular distance between the two. That's it. Right, now some students go wrong over here. Now this is an important step. It is nothing to be afraid of, and this X value, it is very simple logic, but sometimes some students get it wrong. Now this F43T is already at a perpendicular distance of AB. That is this length of the link AB. Since it is perpendicular, that is the perpendicular distance. Now here I have to make one assumption, that is the direction of F43T. So here I am assuming direction of F43T. I am assuming that F43T is going to be acting in the upward direction, or in the anti-clockwise direction with respect to the point A, right? Now why am I assuming it like that? I can also assume it that it is acting in the clockwise direction. We will get to know whether my assumption is right or wrong in the next step. Okay, when we solve and find out the value, if our assumption is wrong, we will get a negative value. Okay, so here F43T, I'm just assuming that since Q was acting in anti-clockwise direction, in clockwise direction, F43T I'm taking it to be acting in the anti-clockwise direction. That's all. So let us solve for moment with respect to point A. Right. So sigma M A is equal to 0. So here it is equal to, let us see what all forces are there on the link. F23 is there. F23 is acting through the point A. So F23 into perpendicular distance is 0. F23 into 0 is 0. So I am not considering F23. Similarly, F43N is acting through the point A, right? The line of action will take it through A. So there also perpendicular distance is 0. So moment is 0. So I am left with only two forces, which are Q and F43T. So Q is acting in clockwise direction with respect to point A and at a perpendicular distance of X. So I am taking Q into X, and F43T is in the anti-clockwise direction. So this is, I am taking it as negative. So I can put it on the other side of the equal to sign. So q into x is equal to f43t into AB. AB is what? AB is the perpendicular distance of f43t from A, or the length of the link AB. Right, so from here I know value of q, I can measure value of x, I know the value of AB. So the only unknown is f43t. So f43t is equal to qx divided by AB. Okay, now if we had assumed this direction as downwards or clockwise with respect to point A, then I would have got a negative sign over here, right? If it is clockwise, then this will be minus, so here also I will get a minus sign. So then I could have said that the assumption is wrong and f43t is acting in the opposite direction to what was assumed. Right, so I got the value of f43t. Now what I'm going to do is I'm going to go to link 4 and I'm going to draw a force polygon for my link 4. So let us see. Force polygon for link 4. Right. So on link 4 I have this f34. I'm taking parallel to this one f34n, and parallel to this I'm drawing over here f34t. Right, now f34t, now this one I assumed it to be in the upward direction, right? So here it is in the opposite direction, that is downwards. And f34n's direction I don't know, but I just know the line of action. Similarly f14. So when we draw the force polygon for the link 4, I will get the direction as well as the magnitude of all the forces that are there over here. So let us see. Yeah, so as step 4 we are going to draw the force polygon for the link 4. So first I am taking known force P. So P is acting in this direction. I will name it as O and A, this vector. So this is P, I'm marking it. Now this I have to draw it as per scale. Now P may be 2000 Newton, 3000 Newton, whatever it is. So Newton I am converting it into mm, and I am taking a suitable scale. So first I draw P as per a suitable scale. Then I know f34t, right? I find out the value of f34t over here. So the same value I'll mark over here, f34t. I got the value of f34t over here. Parallel to this, I'm drawing it over here. Then I have f34n. So f34n I'm drawing perpendicular to this f34t. Right, I don't know the direction yet. No, this will be in the same flow, so that we'll get eventually. Now next I have f14. So from this point I'm marking f14. Both will meet at one point. So this is f14. So here the direction is going to be in the same flow. So P, 34T, f34n and f14. So I got the value of f34n and I got the value of f14. I also got the value of f34. Right, now this is the resultant of f34t and f34n. I am drawing it in the opposite direction to the flow. What is the flow? f34t is like this, f34n is acting. So flow will take the third force like this. So the resultant will be in the opposite direction to it. f34 is acting downwards. Now you can also study it like that, or you can remember, you can use your common sense. Yes, if one force is getting acted, one guy is pushing from here, another guy is pushing from here downwards. So eventually the body will move downwards only, right? One body is pushing from here and one person is pushing from here. So the body is going to eventually move downwards. So that's it. So the resultant will be downwards. So you can remember it like that also. So I got, what all things I got from here? I got the value of F3 for n and the direction of F3 for n. Similarly, F1 for and magnitude as well as direction. And F3 for's magnitude as well as direction I obtained from here. Now I can go back to my link 3 and I can draw the force polygon for that. So here that is our next step number 5. Let us see. So let us draw the force polygon for link 3. Now before we go into that, if we take link 3, let us see, this is the link 3 and I have the force Q over here. I also found out what? I found out F34's direction as well as magnitude. So that I am taking over here, and this is my F43 which is acting in the opposite direction to it. So what did we study at first itself? Whenever a member is acted upon by three forces, what happens? All the three forces converge together at one point and the resultant of all the forces is going to be 0. Right? So I know that this will all converge at one point. So I also get the direction of, or the line of action of F23. Okay. So now let us draw the force polygon for link 3. How do we draw the force polygon? First, we have to take a suitable scale. Preferably take the same scale that we have taken for this in our step 4, because so many scale conversions, sometimes students get a little bit confused. So the scale I am taking Q, in this direction, as per a suitable scale. So Q is 3000 Newton, you can take it as 3 centimeter or 15 centimeter, something like that. Any suitable value is fine. Now, so here, always when you draw the force polygon, you always mark the points A, B, C. Now, I'm left with F43. F43 is in this direction. So, parallel to that, I'm drawing F43. Right. So, the closing side is going to give me F23. Closing side is going to give me F23. And its direction also will be in the same flow. So, what did we get from this force polygon? I got the value of F23. Measure this, convert it back into whatever scale that you have taken, mm into Newton, Newton conversion, whatever you have taken. Convert it back, you will get the value for F23. Right. So to now what is left in this question? We have to find out the torque. Right. We have to find out the torque. So before that, let me just recap what we have done. First, we did the configuration diagram as per scale we have drawn, and then we take the free body diagram. Why we are drawing the free body diagram? So that we get to know what all are the unknowns, and we'll get a clear picture what all forces we have to find out, what all is direction I don't know, What all forces magnitude I don't know. So these things will be clear for us from our free body diagram. So once we have drawn that, what we are doing, we are considering link 3. We are taking F43 into two components, F43T and F43N. F43N is parallel to the link and F43T is perpendicular to the link. After that, what we are doing, we are taking moment with respect to point A, and we are finding out the value of F43T. So F43T's value is Qx into Qx divided by AB. So we'll get a value over there. Once that is done, we can draw force polygon for my link 4. So force polygon for link 4, I am drawing P, that is a known force. I draw first. This is as per a scale, suitable scale we have to take. As per a suitable scale, P I draw first. I got the value of F43T. So parallel to this, I draw over here F34T. Then F34N is perpendicular to it, that I draw. And F14 is always perpendicular to the line of stroke, so that I am drawing over here. So that is done. Once that is done, I get the resultant of F34T and F34N. It is going to be in the opposite direction to the flow. Once I get that, I go back to my link 3. On my link 3, I put up this F34 as F43 in the opposite direction. So then when I draw the force polygon for these three forces over here, Q is the known force, F43 is another known force that I got from here, mark it over here. I'll get the F23's magnitude as well as direction. Now what is left for me is to find out the torque of So the last step, or step 6, is to find out torque, input torque. So how to find out the input torque? I have my link 2, I have T2 acting over here. F23, I got F23 parallel to this, I'm drawing over here F32. So F23 is acting in this direction, so F32 will be in the opposite direction. So this is F12. So what did we learn about a member with two forces and a torque? That is, these two are equal in magnitude, opposite in direction and parallel to each other, and they together constitute a couple. Right, so here they are together constituting a couple. And I have to find out the perpendicular distance between these two. So this is h, perpendicular distance h. Right. So the couple is T2 is going to be minus of F32 into h. So why is this minus sign? Because it is going to be in anti-clockwise direction. And so the input torque to keep the system in equilibrium is going to be in clockwise direction. So T is going to be minus of minus F32 into H. So eventually it is going to be plus sign. So T is the input torque and T2 is the couple. So eventually T is equal to minus of T2. So we will get the value for T2. So that's it, our problem is done. So you can try solving it by putting some values, and let me know in the comments below what you think about the class. Are there any improvements required or any suggestions for the class? Please let me know. And so together we will be solving next 4-bar chain, and that will be it. We'll move on to dynamic force analysis after that. Thank you.